Hey everyone, and welcome back to the channel. Today we are taking a look at something I've been really curious about, the FNIRSI DS215H, a compact 2-channel digital oscilloscope that packs some impressive specs for its size. The DS250H offers up to 50 MHz of analog bandwidth, 250 megasamples per second sampling rate, and even includes a built-in function generator, all in a handheld device that fits easily on your workbench or in your field kit. On paper, it looks like a really interesting tool for quick signal checks, fieldwork, or hobby electronics. I'm excited to find out if this little scope can really deliver usable performance and features in such a small form factor. FNIRSI claims that full support of XY mode, FFT, math operations, and waveform storage. So let's see how it performs in practice. Before we jump in, just a quick note, FNIRSI sent me this unit for review, but there was no payment involved. I'm not required to follow any script, and the review you're watching is entirely my own opinion. As always, FNIRSI will see this video at the same time you do when it goes live on YouTube. A quick thank you to FNIRSI for sending this device over, but most importantly, a big thank you to you, my viewers, who are the true sponsors of this channel and support my work simply by using the affiliate access links on the screen or in the video description whenever you shop on AliExpress or Amazon. It won't cost you a cent more, but it makes a big difference and keeps this channel running. Alright, let's power it up and see what the FNIRSI DS250H is capable of. Looking for fast, reliable manufacturing services? PCBWay has you covered. From high-quality PCB prototyping and assembly to precision CNC machining, they deliver professional results trusted by engineers worldwide. But here's the real highlight: PCBWay's advanced 3D printing services. This month they are offering amazing promotions on TPU flexible printing. Perfect for durable, flexible prototypes, wearables, and custom designs. Whether it's PCBs, CNC, or cutting-edge 3D printing, PCBWay brings your idea to life, affordably and fast. Check out PCBWay today and take advantage of their TPU flexible printing deals. Okay, as always, let's start by the unboxing. It comes in this pretty cool box, a retail box with the normal FNIRSI packing. We have also the specs in the back, but we will see this ahead in the video. Let's start by seeing what is delivered. Okay, we have the usual quality assurance cards from FNIRSI and the device. I will see it in a bit, and let's see what we have below. Okay, so we have a set of probes and a user manual. Let me take the box out of the way. Okay, so we have the user manual in English and Chinese only. The usual organization with graphics, infographics, and yeah, color seems okay. What next? We have a probe. This is the P6100 for sure. Also a charging cable inside, USB Type A to Type C, and alligator clips to MCX adapter. Okay, we have also a BNC to MCX adapter and the probe, as I mentioned before, the 6100. It was delivered also outside the box with a second set of probe and also another MCX to BNC adapter. Okay, and that's it, what we have in the box. Let me just open it. Let's see. Okay, I like to keep this, but it seems hard this time. Okay, that's it. Okay, here it is. For the first impressions, this device reminds me a lot the Miniware devices. It has this metal look. I'm almost sure this is metal body. Not sure about the outside. I'm not sure if this is aluminum or something like that, but the device is pretty small. Yeah. We have these two knobs, knob A and knob B, and on the top we have a few buttons. We have the OK and power and a few other options. This is the menu and the go back key, and the other ones I'm not sure yet, but I will show in the features highlights section. Okay, also USB Type-C connector for charging and connecting to the PC. And on the right side you have, let me show you, channel 1, channel 2 and the output from the function generator. In the back we have this adjustable lever that will allow you to put the device in several positions, more or less as you want. Okay, it will be nice if it was a bit larger, but I think it will do the job. Again, the back, this seems plastic, doesn't seem to be metal. Okay, and in the bottom we just have this hole for the reset of the system. And I think that's it. It seems a very nice construction, a bit different of the usual FNIRSI devices. Let me show you. In terms of small devices, we used to have this one. This is the DS215H. It is the latest from that small family of devices that you have. And for 50 megahertz, we have the DC53P. That it's a much bigger device, but it's also a multimeter. And yeah, it's two different solutions. So we have 50 megahertz in this one and 10 in this small one. This will be somehow in the middle. We have two channels also, like the 2C53P and 50 megahertz, but a small form factor as the DS215H. So seems a nice conjunction between the two of them. Still portable, very portable, and with these two knobs. Okay, that's it. Let's start by seeing how this works. Okay, let's start by seeing how this works. Let me power the oscilloscope, and the first thing that we have to do is to select the language. One positive thing is that we have 8 languages available. While I am Portuguese, I will select English. It will be easier for everyone. Let's do this. And I'm selecting with the button that is the power also. As you can see here on the top, each button has several functions, 2 at least. And this is the power and the OK for the selection. We have here the channel 1 data. Not sure what that symbol is. Play stop, so this is where you run or stop the trigger, auto, and channel 2 properties, menu, and signal generator. Very nice. Okay, so in the screen, let's see what we have. Let me start by doing auto. Okay, seems nice. I have my signal generator outputting 2 simultaneous sine waves. Yeah. At the frequency of 1 kilohertz, no problems there. Everything is very well identified. Voltage peak to peak 3 volts mostly. Okay, and what we have on the screen from the top to the bottom, we have here the run stop indicator. If we stop like this, it will change. Okay, the time division indicator. We can change, let me see the time division. I think that not this one. Yeah, this one. We have to change here. This is the trigger. And again, I believe, yeah, now we can change the time division and the amplitudes for the first channel, like this. And yeah, I'm getting ahead of myself, but we have the time division here, and here we have the controls of the things that you can do on the screen. So on the top also you have the slow mode, for example, on the trigger. Let me see. Let's change again to put this on the trigger mode. On the trigger you can see that it's moving really slow, but if you change here to fast, it will change much faster. Okay, let's put it again in slow. We have also in here the function generator indicator and the battery, of course. Two signals. Okay, so this is a dual, as you can see, signal oscilloscope. And we have on this side the specifics for the channel 1. Now we have 1 volt of amplitude. The probe, it's at 1 time, and it is with AC coupling. On the right side we have the same thing, but for the second channel. And in the middle we have the trigger options. To move everything on the screen, let's go back to this part. We have right now the move in the memory, that's this little triangle, and the arrow for the trigger. So on the first wheel you will be able to change the trigger, and on the second wheel you will be able to change to navigate in the buffer memory. Okay, if you press here on, no, in this one that says C1 1 time, as you can see this vertical, now it's blue. That means that the first knob will adjust the amplitude of the vertical, and the second knob obviously change the time division for both channels. If you press again, the same for channel 2. If you continue pressing, now you will be able, as you can see with the blue arrow, to move the channel on the screen up or down, and the second option will move obviously on the buffer again. If you press again the button, it will change this to orange, so you are controlling the second channel, and finally you are back to the first option. I told you initially that you have 2 options for each button. If you press, you do a long press on the first button, the first button is this one, so the long press will shut down the device. But the second button, as you can see, it says C1. If you press it with a long press, you will be able to see here the options for channel 1. So if it will be on start, on or off, let's see the probe, if it is 1 time or 10 times, and okay, you use knob B, the second knob, to change the options. And the third option is the coupling. You can have AC or DC. Okay, I will leave it in DC. And finally you have FFT on or off, but we will see that in the FFT chapter. Okay, so those are the options for channel 1. You can do exactly the same on channel 2. Just press on C2 for a bit, and you are able to change the options also for channel 2. This start is when you start the device, if it will, the channel will be open or closed. I will leave it on. And what else? We have here also on this third button where you have the T, the options for triggering. So you have the trigger mode in auto, single or normal. You can have it on channel 1 or channel 2. Okay. And I don't know how it came to be here, but anyway. And you have also the edge. It can be a rising edge or falling edge. And in terms of options of what you see on the screen, this is basically it. What else? The final button is the M, and if you press M, it will show you a menu. It's a different kind of interface for what we are used to see in FNIRSI. So in this menu, you will have several icons in the bottom. For example, this first icon is the 50%. Just press it, and I think it's here. Yeah, 50%, and you will put the signals at 50%. and we have some other options. This will take some time to get acquainted since you don't have any text to explain what they do. Sometimes you understand the icon. For example, this is for save, so it will save the image. Let's try it. Okay, and save. Yeah, it will save the image to the memory. This one seems a bit harder to understand what it is, but it is the measurements and the image browser, and finally the settings. Let's go to the settings. This is part of the operation. In the settings part, we have again the chance of selecting the language. You can also set the sound and light. The way this works in this page is you use the first knob to control this menu, this vertical menu, and the second knob, it will control the cursor inside the menu. So sound and light, you can change it like this. If you want to change the value, you press and change it accordingly. Okay. You have the auto shutdown with the off, obviously, 15, 13 minutes and 1 hour. And USB sharing, where you can take the image of the device and probably do the upgrades. The about, so this is the version 0.03 of the DS215H, and finally the factory reset. Okay, I think the factory reset will shut down the device, but no need to do it right now. Okay, in terms of the menu, that's it. If you want to come back, just press M and you are back. Finally, the last option is the long press on the M, and this will start the signal generator, but signal generator, I will have a chapter for it, so we will see this ahead. In terms of the design of the UI, if you saw my latest videos about the FNIRSI products, you probably are aware of this new design. You are more acquainted. The only thing that is a bit different here is these two knobs and this menu system that is totally new in this kind of devices. Other than that, everything seems and works more or less the same way, like the menu here or this indicator for the operation and everything else. Okay, in terms of operation, that's it. Now let's see individually each of these functions and do some bandwidth tests. Okay, so now let me show you some features that are included in this device. Let's start with the 50% doesn't need any explanation. If you have the signals out of the way, it's just to center it. But then you can use the first icon, the measurements, to select which measurements you want to use. So the way this works is the first knob moves the cursor on the vertical axis and the second knob on the horizontal axis. If you want all measurements on, you have the first option to turn it all on, and the second option will do it exactly the opposite, so it will turn everything off. To select some specific values, you just go with the cursor to the value you want, and you select which ones you want to work with. I think we have VPP also here. So to change to channel 2, you just use the cursor and you select with which values you want to work. Okay, in terms of measurements, that's it. Next, on the features, we have this disk that we can select, and it will save the image to the memory as I've shown before. Now, how can you see this image in the memory? You go to menu again, and let's go to the one of the last options, this one that has a picture, and we'll use the OK to select it. As you can see, we have two images in here, and we can use the cursor to navigate. Now we can use these options that you see on the top by using with the buttons that are on top of them. For example, if you want to select the image 1, you just go to this button that is over this icon, and it is selected. With this image selected, you can now, for example, do the operations that you have here. For example, I will delete it. Okay, and with the knob, this one, you can confirm the deletion, and then with OK. That's it. So you have this image navigator for the image that you saved. And to go back, you just use the M key to go to the main screen. I will now talk about the cursors. The cursors are located in this icon, and when you select that option, you have the X and Y axis to activate. Let's activate both, and they are not controlled in this menu. To control the cursors, you go to the main screen, where you have the main channel menu, and using the C1 button, that is also the button used to control this option on the screen, the way the cursors are handled. You press until you get the X1 and I1 option. When you get this option, the first knob will control the first vertical cursor, and the second knob, it will control the first horizontal cursor. If you press again, obviously it will change to the second vertical cursor, and the second horizontal cursor is being also controlled by this. It's not hard. I don't know why these options are not inside the cursor menu, but okay, it's easy enough to work with it in here. What else? Well, you have in a very small letters here all the values calculated. I don't know if you are able to see it in the screen. This in the screen seems to be blue, but in reality it's pink. And yeah, in terms of cursors, that's it. To disable the cursors, you go again to this menu, select OK, and unselect the cursors that you have previously activated. And basically that's it. Now, from cursors, you have next the math functions. The math functions are this small icon with 4 squares, and you can activate it by selecting OK, and then after, when you have this menu, select which function you want to use. We can, for example, have channel 1 plus channel 2, and so on. You have several functions available to you. Let's see this one, for example, and whenever you just don't need anymore to use the math functions, you come here to the first option and select it, the off, to disable it. The next function is the persistence, so afterglow, how they call it. For that, you just activate this menu, the afterglow, and select which value you want to use. For example, 500 milliseconds. Okay, it's activated. If I do a sweep with my function generator, you can see the persistence. Let's see how it does with 1 second persistence and infinite. Okay, it renders pretty well. It's fast to render the signals. Seems okay. Okay, let's disable this and also remove the sweep. And pressing menu again will take you out of this menu. The next option is the XY mode. So since we have 2 channels, we have the possibility of plotting in XY mode. We can always use the 50% to put the circle in the middle. Let me see, 50%. Okay. And the rendering again seems pretty nice. Let's go again to the plotting zone, and I will now use my signal generator function here to animate this. This seems very fast. Let me go back. Okay, like this. It's slower now, and we can also give some speed. Let me see, like this, and we can also add some variations. Yeah. So this seems to work. Okay. Let's go to the main menu and we can play a bit with the settings. If you want to disable it, let's go again to the option of the XY modes. It's this one, and select OK, and you are back to the normal mode. Okay, the next option is the calibration. For that, you have to disconnect both probes. Okay, and let's try to see how the calibration works. This will take a minute or so, so let's wait. I will fast forward. You can see the calibration time on the screen, but one of the questions that a lot of viewers ask me is if we can use the devices while charging. You can see that the charge is almost depleted, and I will connect the power supply and see, yeah, it's charging, so we can use it while it is charging. Let me connect again the probes, okay. And yeah, auto. Let's see. Yeah, it seems to be working correctly. Nice. Let's align the phases. Everything is okay. So for the FFT, this is a function that we have in here. Let's start by selecting the option on channel 1. Let's go here, and in the end we have the FFT option. Let's open it also for channel 2. Okay. And we have the FFT also for channel 2. Regarding the FFT, let's go here to channel 1, start some modulation. Okay. Now we have here the modulation, and we can see somehow in these very small FFT diagrams the waves. I didn't manage to do what I was expecting, so now I'm messing a bit with the time base. You can see the variations in the FFT as I change this. This is a very simple and basic FFT, but it might help you somehow. Okay, so in terms of FFT, this is the function that you have, and yeah, let's move on. So for the bandwidth test, I have my function generator already outputting a 1 MHz signal with a VPP of 1 volt. I'm using the BNC cables terminated by a 50 ohm terminator, and I will have for probe compensation the ×1 and the DC coupling. For the test, I will use the VPP as measurement. This value should not be lower than 710, 20 millivolts, around that, on both channels, but I will start first only with one channel. Let me just disconnect this one, okay, and do a auto again. So we are with the VPP of 1 volt, that's correct, and around 1 MHz signal. So let's start by increasing this to 10 MHz to see how it handles 10 MHz. The VPP is bouncing between 997 something, 10 MHz totally identified. Okay, let me continue. So now I will take it to 25 MHz. Okay, 25 MHz, the VPP, it's a bit low of 700 millivolts, but let's do an auto to see what we got. Okay. If we do an auto, it will show 1.02 volts. Again, this is a bit suspicious because we are at half of the supported bandwidth, but anyway, let's continue. Let's go up to 50 megahertz, the maximum supported by this device. So a 50 megahertz, if I don't do an auto, it's below 1 volt, and it should. Let's do it now, auto, and see what we got. Okay, so if we do a auto, it will show 928 millivolts. That is cycle at 50%, that is correct, and the frequency is also okay. The Sine wave is a bit jumpy, wiggle a bit, but yeah, we can understand this is the maximum of the device. Let me take it manually to see when it go lower than the 700 millivolts. So this should be around 60 megahertz. But anyway, this for me it's a bit suspicious. Let's do now in other way. Okay, I will do an auto at 1 megahertz, and then we will take it directly to 50 megahertz without doing an auto, and the values are a bit different. Okay, but yeah, it seems that we have 783. That is cycle 50%. Let me just something like that, top to top. If this is correct, very nice to see. Okay, now let's go back to 1 megahertz and activate channel 2 to see what we get with 2 channels. So channel 2 let's do auto first, auto set. Now activate channel 2, and we have 2 channels. Okay, auto set again. I will align the signals. Yeah, seems good. Both signals over 1 volt. And let's take it to 10 volts again. 10 volts, yeah, and copy to channel 2. And with 10 volts without doing an auto, we have 1.06, 1.05 on channel 2. Everything seems okay. Let me adjust the time base. Okay. Nice. So 25 megahertz, what do we have? Okay, let's copy again. Channel 2. Still over 1 volt. Again, this doesn't seem to compute, but okay, let's take it. And let's do an auto again. Okay, and take it to 50 megahertz, the maximum bandwidth. So the sine waves are all over the place. The voltage doesn't change, and with 2 channels, 50 megahertz, I don't know. Okay, all over the place the first channel. The second one, even so, it's a bit better. The voltage, it's over 1 volt here, and yeah. So I will do the, sorry, I forgot to do a copy of the channel. Let's do both channels of 50 megahertz. Yeah, never mind. So this is all over the place. What I will do now, it's the same exercise of bringing the channel from, let's copy the channel from 1 megahertz without doing an auto and see what we get. Okay, so let's take it first to 10 megahertz and copy channel 2 at the same. Okay, nice. So the voltage 1.12, 25, copy to channel 2, still maintains the same VPP, and it goes up to 50 megahertz. Copy to channel 2, and yeah, still maintains the same VPP. Okay, that's the results I have. Leave in the comments what you think about it, and yeah, time to move on. Now let's test the signal generator. For activating the signal generator, you press for a while here the M key. And for the signal generator, if you already dealt with FNIRSI devices, you probably will identify this immediately. One thing that seems not to be correct is this off-on signal. It should be on-off. Where do it? Yeah, this is the off, and this is the on. So, and what happens if we put off? It should not appear. Yeah, this one, it will not be visible. It will be disabled. Okay. If we activate it, it will have here this green with a sine wave. Okay, so it is on, not no, but on. And then we have 30 nice different signals. You can see it already outputting the signal on my oscilloscope, the Rigel, the HO 924. And if you go down, you can see all the signals being represented there. At 1 kilohertz seems pretty good. Okay, you can see that they have a few. You can see here the differences. It's not very smooth because the sample rate it's not very high. So you can see here some squares in the signal. But for most of the things should be enough for you. Okay. And what happens if we take this to the maximum? So to work with this, you first use the knob A to move on the signals, on the waveforms, and you will use the knob B to change the values. So right now, for example, to change the sine wave frequency, you use knobs to select the frequency, and then OK, and again, using the knobs you can change the values. Right now I'm going to the maximum. I believe it's 50 megahertz, 50 hertz, so 50 kilohertz. We are at the maximum, and in terms of the frequency, that's the maximum. The amplitude, let's see what we can do. The maximum is 3 volts and the minimum is 0.1 volts. So it's pretty easy also to change with these knobs. Okay, and yeah, let's try again to see auto. Now, since you have a higher frequency, you can see the lines draw better. But also, since we are in a higher frequency, we can see here a glitch. Nothing serious, not too smooth, but we can see that have a small difference. This is the sine wave, also it's 50 kilohertz. Let's see if I don't get this wrong again. Half wave, okay. Full wave. Step wave, let's see. Okay, could be better, but this is the maximum output of the function generator. The reverse step wave, index up, index down, direct current, so this should be outputting 3 volts. Doesn't seem to identify 3 volts, it's 145. Okay, multi audio. Okay, and sync pulse, Lorentz, again, doesn't seem too bad, and this one is the last one. Okay, pretty simple to use. These knobs help a bit while using it. Let's see here on the frequency, duty cycle. Okay, quite responsive. So yeah, that's it. I think this one is a win also. And now is teardown time. Okay, nice. So let's start by confirming the 1500 milliamps hour battery. Okay. And yeah, this seems pretty simple. Let me take the battery out. In terms of layout, doesn't seem to have too much going on. We do have a metallic protection in here. Let's see what is below. You can see here the electronics for both channels. Okay, I think that's time to put this under the microscope and see what is going on here. I have the DS215H already under the microscope, as you can see. Let's start by this side. This is where the knobs are located. You see here the fixing for the knobs. And near the USB Type-C connector, we have the normal TC4056 IC. That is a lithium-ion battery linear charger with constant current and constant voltage. It is pretty frequent in these small devices. And then you have all the buttons that you see on the top. Here is the mechanism. And you have also this IC. So this is a Go-in GW1N UV2. The part number is the KN48C7-16. It has a lot of features. You can see it here on the screen, the datasheet. And it seems to have some connectors here to the side, not sure why. And also you have what seems to be the ADC. If you notice the tracks, they seem to come here to the part of the channels. So this is a common ADC for both channels, for what we are able to understand. And we have also here what should be a microprocessor, MCU, and also the communication part, where you have here some connectors, and again those kind of dots that are also seems to be also connectors. Okay, in these sides coming from this MCU, you have tracks connecting to all these ICs that, for what it seems, are the logic, the electronics for the output of this function generator or signal generator. For each channel, you have here several components duplicated, as you can see, and this is the ONGFA mini signal relay, and you have also the HC4051, that is a analog multiplexer, demultiplexer, so a high performance silicon gate CMOS, as you can see in the datasheet. And also you have this one that is appearing more. I reviewed lately the ERD10, I believe, that has also these components in it. And the GS8092, that's these two, and also you have two more in here. It's a 350 megahertz CMOS rail-to-rail output op-amp. So we have four of them in this circuit. And finally, here in the back, you have the Y240S. This is a 4-pin 400 volts solid-state relay MOSFET. And yeah, you have also two of them, a trim switch to adjust the signal, and I think that is mainly that. We have a few more components, but I will not cover everything in here. And yeah, I think basically that's it in terms of components. A very clean board, seems very well designed, but now it's closing time. So let's wrap things up and see where the FNIRSI DS215H stands after spending some time with it. The overall construction is solid and feels very well put together. The housing is sturdy, the buttons have a nice tactile feel, and the design doesn't give off that budget impression. It actually reminds me a lot of Miniware products, and I mean that as a compliment. Miniware is known for their compact, high-quality tools, and FNIRSI seems to have taken a page from their book here. The portable form factor is maintained perfectly, small enough to slip into a bag, yet robust enough for real use on the bench or in the field. The DS215H offers 2 channels, which is fantastic for such a small device. Many handheld scopes only give you 1. On top of that, it includes a function generator, making it a real grab-and-go instrument for quick signal checks or troubleshooting. And FNIRSI didn't cut corners on functionality. You get XY mode, FFT analysis, automatic measurements, cursors, math functions, plus image saving and browsing built right in. All these options make the DS250H feel like a true Swiss Army knife for electronics. Compact, versatile, and surprisingly capable. The display is bright and crisp enough for both indoor and outdoor use, and navigation through the menus is intuitive once you get familiar with the layout, but you will benefit from previous FNIRSI device experience. Signal and triggering are responsive for this class of scope, and while you won't replace your full bench oscilloscope with it, it absolutely shines as a portable troubleshooting tool or second scope for fieldwork. As of today, the FNIRSI DS250H is available on the AliExpress FNIRSI official store for around 61 euros, which is roughly 65 to 70 US dollars. At that price point, you are getting a dual-channel oscilloscope and a function generator. That's excellent value. While possible, it's hard to find anything else this compact and feature-rich without spending significantly more. So overall, the DS250H is a well-designed, feature-packed handheld oscilloscope that offers a lot for the money. You get solid construction and compact design, 50 MHz scope with 2 channels, a built-in function generator, XY mode, FFT analysis, math functions, and measurement tools, all packed with a very accessible price for anyone who needs portable scope for quick measurements, fieldwork, or hobby electronics. This little device is hard to beat. And if you'd like to support the channel, remember that you can do so just by using the affiliate access links in the screen or in the video description when shopping on AliExpress or Amazon. It won't cost you a cent more, but it truly helps keep these reviews coming. If you enjoyed this video, please slap that like button, and if you are new here, consider subscribing so you don't miss future reviews of the latest test equipment and electronics tools that every week arrive to my workbench. That's all for today. Thank you for your time and company, and I'll see you in my next video. Until then, take care and happy measuring!